Alright, so we're going to continue from the previous video. I got cut off by the time there, so I only have a 10-minute window here. But anyway, we had said that the radius of the outer function, or the outer radius here, was going to be 8 take away the distance of this y value here. Well, that was 8 minus y. We came back to our diagram to see that this function right here was given by y equals 4 ln of 3 minus x. So the radius of the outside, here is 8 minus 4 ln 3 minus x. So we're going to use that in our formula here in just a second. We'll go ahead and plug it in. There. But let's go ahead and figure out while we're at it. Let's go ahead and figure out the radius of the inner circle here. So again, the radius of the inner circle will be the distance. It'll be the distance from the center. So we're going to look here from the center to the innermost part. So we can think about, again, going from let's say 8, we're here at 8, to maybe going to about here. This is where the circle, the inner circle lies. It lies in between this gap here. Well, what is this height here? Well, this is just the horizontal line. Y equals 6. So I ask you, what's the distance from 6 to 8? What's the radius there? Well, you would just say 2. Well, that was pretty easy to find, and you would just say that R in is equal to 2. Again, it's just the whatever the axis is that we're rotating about. So we're rotating about the axis y equals 8, and we're going to take away our function. Well, our function was 6, so 8 take away 6 gives us a distance of 2. So here our radius for the inner part, our inner radius is just 2. And what we're going to go ahead and do is plug that in there as well. And if we do all this, we get something that looks like this. We get pi, let's see. We're going to have r or the outer radius, I should say, the outer radius squared. Well, the outer radius was this thing up here, so it's going to look like this. It's going to be 8 minus 4 ln 3 minus x, but remember we have to square it all, right? So that's the outer radius squared minus, we have a minus here, the inner radius squared. Well, what was the inner radius squared? Well, we said that the inner radius squared was 2, so 2 squared gives us a 4. And now I'm just going to close off my bracket here, and we have our delta x, our change in x there. Now, my question to you is, this is it. This is the formula that we need to find the volume of one washer. But we don't want just to find the volume of one washer. What I'd like to do is find the volume of the entire figure. So again, you need to think about cutting maybe infinitely many. So what if I did infinitely many washers here? So what if I started cutting a bunch of washers here, and I started calculating the volume of all the washers that I was finding, and I started adding all these washers together. Well, I'm accumulating infinitely many washers, so I'm going to be using an integral here. So that's what we're going to do. We're going to go ahead and integrate. We're going to integrate. So if I want the total volume, volume, and I'm going to write subscript with the total. So this is the total volume. That's going to be equal to the integral, and again, we're going from 0 to 2. According to our picture, we're going from 0 to 2. And this here is my function. This here is what I'm going to integrate. This here is the volume of one solid, or of one washer, I should say, one washer. And I'm going to accumulate infinitely many washers from 0 to 2. So I'm going to have pi, and I'm just going to copy this whole thing here. So I have 8 minus, let's see, 4 ln of 3 minus x, and all of that is squared, minus 4, and then I have dx. Now again, you don't have to do this integral by hand. You can easily just type this into your calculator and get your answer. And in fact, I highly recommend you do that, given that this is a calculator question. And if you plug all this thing, if you plug if you plug this integral into your calculator, you should get 168.179, or if you round up a little bit, you should get 168.180. So again, stay tuned. In the next video, what we'll work out is problem C in the next video.